Hello everyone. I am Madhulita Sundarai from KGRD College of Engineering and Technology, Associate Professor in Physics. So today we will discuss about time independent Schrodinger equation. So let's get started. Here we will see that the wave function representing a particle of mass m moving having velocity v along x-axis, we can represent this as psi of xt equal to, I will write here, psi of xt with respect to position and time equal to constant e to the power I kx minus omega t, where this equation represent where x is the position of the particle or displacement of the particle, t is time, and k is a wave vector, and omega is the angular velocity of the particle. So if you are taking this is your wave function, here I will write here what will be the our equation, time independent equation. I have to first find out the energy equation and momentum equation. Here I will take del of psi with respect to del x equal to how much, all of you know the derivative. Here I will write del by del x of psi function is e to the power I kx minus omega t. We have to derive this one. Then equal to, we'll get this into, again we have to derive I kx, del by del x of I kx. Okay, equal to how much we will get here, del by del x, you will get e to the power I kx minus omega t into what will be the derivative of this one, ik will be constant, del x by del x is 1, then ik. Here we will get ik is constant, then a e to the power I kx minus omega t is psi. We will get here ik psi, del psi by del x. Okay. Then here we will get, now we will find out del square psi with respect to del x square. Equal to, again we have to derive this equation with respect to del x. Then del by del x of ik into psi equal to, we will get ik is constant, again del psi by del x. How much we got here, del psi by del x, ik into psi. Okay, here I will write here ik into psi. Already we derived everything. Then I will get here I into I is I square equal to minus 1. We get here minus k square psi. It's okay. Then it's over del square psi by del x square. Then del psi by, with respect to time we will find out now, del psi by del t equal to del of del t with respect to a e to the power I kx minus omega t derivative equal to a e to the power I kx minus omega t into del by del t. What is the time dependent function here, minus I omega t. I will take here again derivative of this quantity, minus I omega. I will get minus of I omega equal to, this function is psi, then minus I omega psi. Is it clear up to this? Del psi by del t. Then I will put here equation number 1. This is first wave equation. This is equation number 1. This is equation number 2. This equation is number 2. This is equation number 3. Del psi by del t is equation number 3. Okay. Next we will find out here del psi by del t is over equation number 3. But the energy, we know that the energy E equal to h nu from the energy E equal to h nu. The energy E equal to h nu. But if I will multiply here 2 pi and divided by 2 pi, then 2 pi nu equal to frequency, 2 pi nu equal to angular velocity, omega h equal to 2 by 2 pi equal to, here I will get h by 2 pi is our h cross, omega h cross. I will give here equation number 4. Equation number 4 I will give this one. So where here h cross equal to h by 2 pi and omega equal to how much? Omega equal to 2 pi nu. Is it clear? Next I will type for momentum. P equal to how much? From de Broglie hypothesis we know P equal to h by lambda equal to, I will multiply here 2 pi and divided by 2 pi lambda equal to 2 pi h by 2 pi lambda. Is it equal to h by 2 pi equal to h cross? H cross here 2 pi by lambda. Okay, then 2 pi by lambda we will find out this one equal to k. This is equation number 5. For your convenience you can write here equation number 5 where h cross equal to where k equal to 2 pi by lambda. Is it clear? Next, total energy of free particle. We know the equation. Total energy of free particle. Total energy equal to total energy of free particle of a free particle. We will take that free particle equal to E equal to, I will write here, E equal to P square by 2m in terms of momentum, P square by 2m equal to, I can write P equal to h cross k, h square k square by 2m. This is equation number, I will give this one equation number 6. Okay, next I will see here E equal to h square k square by 2m. Then I will multiply previous equation what I showed here. See here this equation del psi by del t, our equation number 3, del psi by del t equal to minus I omega psi. I will multiply this both side of equation 3 into I h cross. I will multiply both side of equation 3, multiply equation 3 with I h cross. Then I will get here the equation I h cross del psi by del t equal to h cross omega psi. Clear? Next, this is one equal to I h cross del psi by del t equal to h cross omega equal to how much? H cross omega from equation 4, it's E psi. I will give this I h cross del psi by del t equal to E psi. But E equal to how much we know here from equation 6, we know that I h cross del psi by del t equal to s square k square by 2m into psi. Okay. Then from equation number 2, see here k square equal to, we will get here del square psi by del x square equal to minus k square psi. I will put this equation in this equation. Then here k square psi instead of k square psi, I will keep minus del square psi by del x square. Then the final equation will be here I h cross del psi by del t equal to minus s square by 2m del square psi by del x square. Okay, this one I will give, what will be the equation number here? Equation number 7. Equation number 7. Okay, If I will find out the total energy, this is all about our kinetic energy. If here I will find the total energy equal to kinetic energy plus potential energy equal to, I will write here E equal to P square by 2m plus V of potential energy. Then I will write that equation as, I will write this equation as the time dependent Schrodinger equation. I can write that one as, I can write this one E equal to, how much I will write here, I s cross, I s cross del psi by del t equal to minus s cross square by 2m del square psi by del x square plus v psi. I will keep this equation number 8. Already over 7, this is at 8. Then in 3 dimension, how we will write the equation? This is all about our 1 dimensional equation. It's only along x-axis. I will write here now for 3 dimension. For 3 dimension, what will be the function of psi? X, y, z, t. Okay, all systems it will come x, y, z coordinate. I s cross del psi by del t equal to minus s cross square by 2m. Okay, minus h square by 2m. I will write here del square psi by del x square plus along y axis del square psi by del y square plus del square psi by del z square plus v of psi. It is the equation in 3 dimensional. Otherwise, I can write here I is cross del psi by del t equal to minus s cross square by 2m. What I will write here? Del square psi plus v of psi, where del is the Laplacian operator, that we can write as del square equal to, I can write del square x square plus del square del y square plus del square by del z square. This is known as Laplacian operator. Laplacian operator. Okay, this is known as, this equation is known as, this is, I will give one equation number here. This equation number 9 is known as time dependent Schrodinger wave equation. This is very important equation, this one. Okay, this is known as time dependent Schrodinger equation. Now we will find the time independent Schrodinger equation. Schrodinger equation. How will write? This is depend. This factor is depend on the time. We will find out this. We will place that equal to E psi. Already we discussed on the equation number. I will show you that equation. See here, E psi. Okay. Then I will replace that one into E psi. Okay. I s cross del psi by del t equal to E psi. I will put this equation as here. Here I will write here I s cross del psi by del t equal to E psi. E psi equal to, I will put here E psi minus s square by 2m del square psi plus b psi. Okay. Next slide I will go. Next slide. Next I will type here. I will put that all the equation to the left side. I will get here s square by 2m del square psi minus b psi plus e psi equal to 0. Then here I will get how much del square. I will multiply with s cross square by 2m both sides. Del square psi minus 2m by h cross square. I will take psi common, psi If I will take plus sign here, I will get here E minus B equal to 0. Okay. Then this one, I will type, this one is your 3-dimensional. Okay. Your Laplacian operator is here. It is a 3-dimensional time independent Schrodinger wave equation. This is 3-dimensional time independent Schrodinger equation. Okay, this is time independent Schrodinger equation in 3 dimensions. Next, I will see that for 1 dimension, how will write? Just put here del square psi by del x square plus only for 1 dimension you can write 2m by h cross square psi e minus b equal to 0. This is equation number I will give for 3. What is the equation number? This is equation number 10. I will give here equation number 10. This is time independent wave equation, and this is 1-dimensional time independent Schrodinger wave equation. Thank you all.